So, good morning everyone. Today we are going to discuss about the chapter gravitation. So, before directly jumping into this definition of gravitation, first we need to know what is the application of gravitation or how this concept of gravitation will work on the universe. Now, let us suppose I have a pen on my hand. So, if I will release this one, so this will directly go to the downward direction. Now, why this pen will go to the downward direction? Because the earth has the capacity to attract every object towards its center. Now, what is the power of that earth? So, that power is known as gravitation, or we can say gravitational force. So, by the help of gravitational force, the earth has the capacity to attract every object towards its center. Now, when the further experiment has been done, so we just conclude that not only the earth has the gravitational force, but also every object having some mass will have the gravitational force. Now, see, if we are having two objects, let us suppose this is object 1 and this is object 2, this one of mass m1, this one of mass m2, and if there is a distance separation between these two mass is r. Remember, the distance should be between the two center of the objects. It is not like this is the distance, no, this is not the distance. So, we will have to find out the value of distance from this center of this object to the center of this object. So, then only we can able to find out the value of gravitational force. Now, so how much force will be acting between these two objects? So, that force will be proportional to or directly proportional to the product of two masses. That means, with the help of this expression we can able to know that if the mass of the two objects will increase, then definitely the force between these two objects will also increase. Similarly, at the same time this force will be inversely proportional to the square of the distance between them. That means what? As we can see, this r square is in denominator term. That means, the value, if the value of the r square will increase, then the value of the force will decrease, and if the value of r square will decrease, the value of force will increase. That means what? This means what? The inversely proportional, and this means what? The directly proportional. So, in case of directly proportional, if the quantity that is there in the right side, if it will increase, then the quantity that is there in the left side will also increase. Similarly, if it is inversely proportional, then the quantity that is there in the denominator of the right side, if it will increase, then definitely the term that is there in the left side of this proportionality symbol will decrease. See, if we will give this as equation 1, this as equation 2, combining equation 1 and 2. If we will combine these two equations, so we will get what? F is proportional to m1 into m2 by r square. So, this is what? This is the combination of equation 1 and 2. Now, if I will remove this, if I want to remove this proportionality symbol, what I will do? I will multiply a constant along with the right side term. That means what? See, this proportionality symbol will now change to equals to, and what is the difference between these two? There is a constant that is there is multiplied. That means what? So, this is what this is what is known as the value of gravitational force, or in turn we can know this as universal law of gravitation. So, what is the meaning of universal law of gravitation? That means what? Universal law of gravitation means what? That the gravitational force is not limited to the earth only. It can be used in any object having some mass. If an object that has no mass, the gravitational force concept will not be there. Similarly, we can know that this g is known as universal gravitational constant. This g is known as universal gravitational constant, whose value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now, if you will ask that from where did you get the value? No, we will get the value using the Cavendish experiment. We will discuss in the later classes. So, the value of G is found out to be 6.67 into 10 to the power minus 11 Newton meter square per kg square. How the unit become Newton meter square per kg square? See, we have the formula F is equals to G m1 m2 by r square. The force has the unit itself Newton, this r square has the unit of meter square, and there are two masses multiplied, that means what? Kg square. So, G has the unit of Newton meter square per kg square.